Good morning, Geometry Honors students. So this is Mr. Chen again. So today I would like to talk about sections 1.5, the second half, along with that section 2.5, addition and subtractions properties. So objective for the lesson today, so the first one, apply angles or segment addition properties. Number 2, apply angles or segment subtractions property. So for the segment addition property, so if a segment is added to two congruent segments, the sums are congruent. Angle addition property, if an angle is added to two congruent angles, so the sums are still considered congruent. Congruent, that means they have the exact same measurement. So now, we'll take a look at that, some of the example here, especially for the proof as well, the two-column proof. So the segments or angle subtraction property, so let's say that if a segment or angle is subtracted from the congruent segments or angle, the difference are congruents. Okay, so if those angles, they're already congruent, so once you subtract, so the remaining angles, they're still considered congruent. So now, check it out, the first example. So given that angle BAD, so angle BAD would be this one right here. And then angle CAE, so those two angles, they're congruent. So I just put a little tick mark or the art right here. And then you want to prove that angle BAE, which is this angle. Okay, so let me use different color. So angle BAE, it's congruent to angle CAD. Okay. So in order to prove those two angles are congruent, so always we need to start it with the given. So the first one, so the given statement, so angle BAD is congruent to angle CAE. And then the next thing that I want to show, so according to this two angle here, so one thing that they share in common is that angle DAE. So once you add that angle BAD along with that angle DAE, and you'll end up with the exact same measurement as angle CAE plus angle DAE. Okay, so this one you can just use one of those postulates, so segments or angle subtractions or the addition. So this one will be saying that it's an angle additions property. Okay, so and then after that, so this one you want to say that angle BAE is congruent to angle CAD. And then this one, so since they pretty much have the exact same angle, so we can say that's angle congruency. Angle congruency property. Okay, so that's one of the examples. So now let's see. So here's another one. So segment OR, it's congruent to segment ST. So as you can see, that I put a little tick mark here already. So QS, that's 5x plus 17. You can always annotate it. And then RT, and that's 10 minus 2x. And also RS, it's already given, which is 3. And now you want to find out the measure of segment QS, okay, QS, and then QT, the entire segment. So start out with that QS. So QS, this one consider the additions, segment addition property. So QS is consider QR, consists of QR, and also segments SR or RS. Okay, so in order to find out QR, so one thing that we notice, QR and ST, those are considered the congruent segments. So basically what we can do here, so 5x plus 17. So basically you can just set that equal to 10 minus 2x by using the segments congruency postulates, because that QR plus RS is the same as ST plus RS. So basically those two segments, they're equal. Okay, so this one basically using algebraic solving equation technique. So this one at 2x on both sides. so we do have 7x. And then 10 minus 17, then we do have negative 7, so that means x equals negative 1. Okay, so 5x plus 2x, 7x, 10 minus 17, negative 7, so x equals negative 1. So QR, so let's find out what that is. Well, QS is already given, so it's 5x plus 17, so there's no need to use that segment addition. So basically just find out, after you find out x, and then you just plug in a number back to the 5x plus 17. Okay, so 5x plus 17. So 5 times negative 1, negative 5 plus 17. So then that will be considered 12. And then QT, so QT is the measure of the entire segment. So QT, so once we find out QS, so we do know that QS and RT, they're exactly the same. Okay, so QS and RT, they're exactly the same. So basically what we can do here, so we just want to find out that the sum of those two line segments. So since we find out QS, so we can just subtract this one by 3. Or another thing that we can do, we can simply just add it, so there's no need to do it this way. So this one is 12, so here's another one which is 12, so we just want to subtract 3. Okay, so instead of doing this way, because that is being overlapping, the QS and also SRT, so they're being overlapping with that RS. So basically we just combine that 12, and here's another 12. So we just want to subtract 3, because that's, 3, that's what they share in common. So 12 plus 12, then that'll be what? 24 minus 3. So then that's 21. Again, the reason why that I need to subtract 3, because that 3, we use that twice. It's overlapping. So for QT, so that's just 21. So this one's kind of like a union thing. So the union, so you want to subtract the intersections, things that they share in common. So let's say that we do have a Venn diagram here. So whatever the element that you have right here for the circle, you want to combine them, and then you want to subtract the one that they share in common. So then that you'll get the total. Okay, so now let's see what else that we have. So given that angle BAD, once again, is congruent to angle FAD. So ray AD, so it bisects angle CAE. Okay, so this one bisects. So if this one is being the angle bisector, so that means these two angles got to be congruent as well. So you want to prove that angle BAC. Okay, so angle BAC. This angle right here is congruent to that angle FAE. So basically what we can do here, so start with that given. So angle BAD is congruent to angle FAD given. So since we do know that these two angles are congruent, so another thing that we notice, AD bisects angle CAE. Again, this one is also given. So again, anytime they see the ray bisects an angle, so that means we'll come up with two congruent angle automatically. So for that angle, the one that I put in the double R right here, so angle CAD, so this one is congruent to angle EAD. And the reason for this one is called the angle bisector theorem. Okay. So for those you might be wondering, why do we need to come up with those two congruent angles? Well, the thing is that we can apply that the angle subtractions postulates. So one thing that we notice, angle BAD minus angle CAD, and you'll end up with the exact same angle of angles FAD minus angle EAD. Okay, so this one here, we can just say that it's angle subtraction postulate. And then after that, so we can say that angle BAE is congruent to angle FAE. And this one you want to state that angle congruency property. Okay, so it's a 5-step proof. So for the statement, so you want to show that the things that you want to come up with the conclusion. And then on the right hand column here, so this one you want to just put in the justification or the reasons. Okay, so here's another one. So angle A, it's complementary to angle B. Angle C is complementary to angle B. Okay, so if those two angles are complementary, so that means angle A plus angle B equals 90 degrees. Angle C is complementary to angle B, so that means angle C plus angle B, it's also 90 degrees. So here's the expression for the angles. So angle A, angle B, angle C. So again, it contains with two variables, so that means we need to apply the linear system equation. So how do we set up the linear system equation? So one thing that we notice, so angle A plus angle B, so 3x plus y, so plus x plus 4y plus 2, so that equals 90 degrees. So that's the first equation. And then the second equation is that angle C plus angle B, so 3y minus 3, plus angle B, so x plus 4y plus 2, so that also equals 90 degrees. Okay, so for those you might be wondering things that we can do here, can we just subtract those two equations before we simplified it? We can combine the like terms, or basically we can simplify it. So it depends on which way that you want to do it, because they're both considered 90 degrees. So if angle A plus angle B equals 90, angle C plus angle B equals 90, so that means angle A is pretty much the same as what? Angle C. Okay, so because they're both complementary. So another thing that we can do, we can just say that, so 3x plus y equals 3y minus 3. If we try to do it this way, we can apply that substitution technique. But once you set up the equation with the first two property or the definitions, complementary angle, so basically we can eliminate all this out. Okay, so once we eliminate it, so we got 3x plus y minus 3y minus 3, then that'll be 0. Okay, you can do that. But the thing is that it's better to simplify it by combining the like terms. So 3x plus x, then that'll be 4x. Y plus 4y, then that'll be 5y. And then 90 minus 2, then that'll be 88. Okay, so just combine those like terms. And then the constant, just move that to the other side. So the other equation here, so basically we want to do the same thing. So x, bring it down. So 3y plus 4y, then that'll be 7y. Negative 3 plus 2, then that'll be negative 1. Add 1 on the other side, so then that'll be 91. And then from here, you want to solve for x and then solve for y. So making sure that the equation got to be written with the standard form of a linear system. So standard form is like ax plus by equals c. And that's exactly what we have right here. So check that one more time, the first two equations. So 3y, 4y, 7y. X, bring it down. Negative 3 plus 2, negative 1. But you want to add 1 on both sides. So that turns out to be 91. First equation, 3x plus x, 4x. Y plus 4y, 5y. and then 2, subtract 2 both sides, so you do have 88. And now what we can do here, so basically we can just find out things that they share in common. So multiply the second equation by 4. Okay, because you want to line up with the same coefficient, so we can subtract. So first equation is 4x plus 5y equals 88. So second equation is 4x plus 28y. So that equals 4 times 91. So 364. And then subtract the equations. So subtract the first one from the second one. So 4x minus 4x, so that's 0. 28y minus 5y, 23y. And then 364 minus 88, so 14 minus 8, so that's 6. And then 5, 15 minus 8, 7, so 3 turns out to be 2, 276. So this one you just want to divide it. So 276 divided by 23, is that divisible? Okay, it looks like it's not. Okay, let's see. So 276 over 23, it is divisible. Okay, so that would be 12. And then solve for x. Okay, because you want to solve for that, solve for b. Okay, so this one we need to plug in back the xy value to the expression. So solve for y and then solve for x. The way to solve for x, just plugging back to the first equation. So 4x plus 5 times 12, then that would be 60, equals 88. So 4x equals 88 minus 60, so then that would be 28, so x equals 7. So once you solve for x and y, so you just plug in the number back to that, the expression for angle B. So angle B, then that would be x, 7, plus 4 times y, so 4 times 12, which is 48, and then plus 2, so 48 plus 2, 50, plus 7, so 57 degrees. Okay, so that's it. So thank you for watching the video today. So again, if you see anything that's more complicated or kind of difficult, so make sure that you need to rewatch the video. Either you want to fast forward, rewind, okay? So thank you for watching the video once again. So if you guys do like the channel, so please subscribe it, and I'll see you guys next week.